Hi everybody, I'm Joy.
I'm Taylor.
I'm Dylan.
Today we're going to go through and cover our project that we had to do, which was about blood alcohol content. We were given a problem where we had to use different variables that we were given about the body fluids and all that jazz, and go through and determine a person's blood alcohol content using different variables. We were given 3 different scenarios. The first scenario is where an individual is to down a 6-pack instantaneously, which is unrealistic, but how they wanted us to do it. And then the second problem was that they drink that 6-pack over a period of time. And the third problem is a more random way of figuring out when a person is drinking and how much they're drinking. So for problem 1, we had to go through, that was kind of where we had to set up all the mathematics behind it. We had to determine an overall function where we figured out the number of drinks, multiplied that by the grams of alcohol consumed, divided by the body fluid, and then multiplied that by 10. Up in our communication cells, we first had to figure out the different formulas of converting weight in pounds to weight in kilograms. And then from there we had to determine the amount of body fluid for that weight. We were given that that for an average female, she has 0.65 kilograms or kiloliters of fluid in her body per kilogram of weight, and a male has 0.68 kiloliters of fluid per kilogram of weight. So we made those conversions. And then another thing we were given was that they eliminate 12 grams, or they eliminate 12 grams per hour of alcohol. We had to convert that to grams per minute. And then overall blood alcohol content is generally in terms of grams per 100 milliliters. So we changed that to elimination in grams per minute per 100 milliliters. So our initial cell was setting up just the downing 6-pack, which was the 6 drinks times, we used regular beer, so 13.6, and then dividing that by the body fluid, and so that was this one, and then multiplying it by 10 to keep it in terms of per 100 milliliters. Went through and determined that after 186 minutes, the male would be able to legally drive at a 0.08 blood alcohol content, and a female could drive after 255 minutes. This is with using a 130-pound female and a 180-pound male.
Okay, for problem 2, it is fairly similar to what problem 1 is, except instead of just downing a 6-pack beer immediately, the person is constantly drinking it over time. And we chose just because we felt like it would fit like what a normal person could drink a 6-pack over. What I think, a person who has drank for a while could drink a 6-pack over. I said 90 minutes, and the equations and everything are the same, except for the fact here that what we're going to do is that we split up the drink. We took 6 drinks over 90 minutes, so that's 1/15 of a drink, 1/15 of a beer per minute here, and so in this case, each minute he or she is drinking 1/15 of a beer for 90 minutes, and then after, as you can see here on this graph, it stops. We have them stop at 90 minutes, and then after that, the elimination rate is just the elimination rate on its own, and the body starts to get rid of the alcohol at that constant rate. So at about, I would say, about 180 Yeah, I've got 190 here for the male, I believe, and then the female this is reaching the legal driving limit, and the female reaches about 206. It's about 260 roughly before they reach that point.
Now for problem 3, this was more of a random amount of drinks or how much they're drinking at a certain time, and we didn't want to go over them drinking 25% of their alcohol in 1 minute. So we set up an if function, so where if the random number is less than 0.5, it's 0, and if it's false, and then they take that new random number times 1/5 plus 1/20th to get a number that lies in between 0.05 and 0.25. And then we use a similar formula like we have in the previous problems, except this one has an if function to where if their blood alcohol content gets above 0.2, we have them stop drinking, and then once it's below it, they start drinking again, because we don't want them to drink too much and die, maybe get a coma. And then you can see on the graph how it levels out pretty much at 0.2, going up and down, so they're still having drinks. And then we added on the graph the coma line, which is 0.4, and the death is 0.5. And then the legal driving limit is 0.08, which they won't get to anytime soon.
We chose to do this because overall a person kind of starts to feel like they're getting sick. Generally, we figured probably around 0.2, so when you start feeling sick, you kind of back off of when you're drinking, and then people around you are drinking, so you kind of drink a little more. This also is hard to fully determine how much they're drinking and stuff, because they may choose to go home after 200 minutes, at which point, or to totally quit drinking after 200 minutes, which then at that point, it would be to determine when they would be able to drive. But this one was not concerned about when they're able to drive. It was just wanting to know the blood alcohol content, and then it wanted us to specify the coma level and the death level. Overall, our problem, we were to make 3 different assumptions. Our first assumption was given to us, that we assumed that they consumed the 6 beers instantaneously. The second one was we decided to take an average of to where they were drinking it within 90 minutes, which we figured would probably be pretty suitable for a partier, a teenage partier. And then the third problem wasn't really any type of assumption beyond the fact that we assumed we had to find a random variable, or a random way of generating if the person is drinking, and if so, how much they are drinking.
We had a few variables to go along with all this. I mean, the variability of this whole project lied in how many drinks we made them have. Like in the first 2, that was fixed, but in the second, in the third one, it was more. I mean, I mean, there was a limit to it, but it was still. I mean, it wasn't exactly 6 beers
and
specified.
Then we go through too, as it's going, we kept track of how much they are drinking, so that we can see that after 90 minutes they still consumed close to 6 beers, which is kind of the number we were shooting for.
Yep. And some of the strengths and weaknesses for this project. Definitely some weaknesses. We don't have all the variables like we need to complete accurate, like metabolism or amount eating, if they've been eating or they're on an empty stomach, or whether or not the person is healthy or not. And then some of the strengths. I mean, there's a lot of biological background and effects on the body. And given our variables, I mean, it is pretty accurate, but not as accurate as it probably is in the real world.
Not as accurate as an actual breathalyzer would be.
Yeah. And that's our project.